So this video is on the trends in the halogens, which are the group 7 elements. And our two aims of this video are to be able to explain the trend in electronegativity of the halogens and to explain the trend in boiling point of the halogens. So the first trend we're going to talk about is the electronegativity trend, and we know from our work from Chem 1 that the electronegativity of the elements in the periodic table increase as you go up the groups. And the reason for this is due to the proximity the electrons can get to the nucleus as you go further up the group. As you go further up the group, there are less shells of electrons shielding the nucleus, and so that nucleus is more attractive to the electrons in the covalent bond that may be formed between the two elements involved. So to explain this increase in electronegativity up the group, you'd say that there are less shells of electrons up the group, and so there is less electron shielding. And so therefore a greater electronegativity. So again, to explain the boiling points and melting points of the halogens up or down the group, we can use our knowledge from Chem 1. First we'll look at what state each of the halogens are in at room temperature. So fluorine is a pale yellow gas. I don't know if you can see that, but I've written gas next to fluorine in yellow. Chlorine is a green or a pale green gas. Bromine is an orange liquid, or an orangey browny liquid. Iodine is a grey solid. Acetine, however, is radioactive, and so it's very difficult to know what it looks like. It's probably a solid, but it breaks down. It has a half-life of about 8 hours, and so we don't really have to worry about acetine in this trend, to be honest. I'll just cross that out at the bottom. So you can see that as you go down the group, we go from a gas to a liquid to a solid. So the melting point is obviously increasing, and the boiling point as well. So we have an increasing MP, melting point, and boiling point, because they're linked together. And the question is why. So all of the halogens go around in pairs. So we have fluorine is F2, chlorine is Cl2, bromine is Br2, and iodine is I2. The fact that the two atoms joined together the same means that they only have van der Waals forces holding them together. And as you go down the group, the surface area of the molecule gets bigger, and so the van der Waals forces get stronger, which sounds familiar, doesn't it? So I'll just write that out for you. So they all have a molecular crystal structure. So they're held with van der Waals forces. And the surface area of the molecule increases. Down the group. So van der Waals forces also increase, which means it takes more energy to break them apart. I hope that helps. Please email me if you need any more help.